At 2:47 UTC, a quiet line on the infrared telescope facility display lifted as if taking a breath. 3i Atlas, dim beyond Jupiter's orbit, issued a pulse that wasn't photonic brightness, but a subtle phase irregularity, a heartbeat in the noise. Crosschecks flickered in from Mauna Kea and Paranal, timestamps aligned, baselines wavered, telemetry drifted out of calibration by fractions that felt intentional. Then the stream froze. Consoles locked, channels hushed, and a single instruction moved through the system like a tide: suspend transmissions. If the object did not brighten, what responded in our instruments? And in the stillness that followed, who was truly listening? When 3 Atlas first appeared in 2024, its presence was a whisper at the edge of vision, a soft glint against the deep cold between Jupiter and Saturn, faint enough that it might have been dismissed as noise. Yet its path curved with too much intent, its velocity too great for anything born of our sun. At first, the data was met with quiet excitement. Another interstellar traveller, another fragment of a distant system briefly crossing ours. But as light curves were plotted and spectral data refined, the object began to betray small, uninvited peculiarities. Its brightness shifted not with spin but seemingly in answer to our gaze. Its infrared signature pulsed in a pattern that mirrored the intervals of our transmissions, as though observation itself altered the thing observed. Across the agencies, NASA, ESA, JPL, instruments were recalibrated, compared, recalibrated again. The numbers refused consistency, and that inconsistency became the mystery. Was this a coincidence of physics, or a form of cosmic feedback too subtle for current understanding? Some called it statistical illusion, others felt something wordless stirring behind the data. The more precisely we measured, the more uncertain we became, as if the universe had noticed we were looking. It began not with revelation, but with error. A routine nightly sweep from the Pan-STARRS observatory caught a faint streak that refused to align with predicted trajectories. The software flagged it as noise, a data artifact caused by cosmic rays or instrument drift. But when analysts at the Minor Planet Center revisited the exposure, they found the trace repeated, frame after frame, moving too fast for any distant comet, yet too steady for a near-Earth object. The trajectory cut obliquely through the ecliptic plane, crossing the paths of the outer planets at an angle that made no gravitational sense. It was as though the object had entered from elsewhere, slicing through the solar system like a quiet visitor unaware of local rules. For weeks, it was just a curiosity shared in late-night emails and lab corridors. Astronomers compared parallax data, cross-checking with infrared readings from Hawaii and the Atacama Desert. The object, designated 3i Atlas, glowed faintly in the mid-infrared, revealing a surface that absorbed more light than it reflected. That alone was peculiar, for most interstellar bodies tend to scatter sunlight erratically as they tumble through space. This one seemed deliberate in its dimness, as if it carried its own shadow with it. Preliminary analysis estimated its size at a few hundred meters across, elongated, maybe spindle-shaped, but the numbers carried margins of uncertainty too wide to trust. It was like trying to study a lantern seen through fog. The first mystery emerged in the photometry. Standard light curves, graphs of brightness over time, should rise and fall with predictable rhythm as an object rotates. Yet 3 Atlas's curve wavered irregularly, its peaks offset by fractions of a second that grew longer with each observation. Some researchers suggested non-uniform composition, perhaps ice sublimating unevenly, causing jets that nudged its spin. Others suspected instrumental timing errors. But when independent teams at the European Southern Observatory replicated the data using separate equipment, the same strange pattern appeared. It wasn't a timing fault, it was real. In Pasadena, at the Jet Propulsion Laboratory, a small group began monitoring the object's infrared emissions through the Deep Space Network's passive listening array. The data flowed in whisper-thin trickles, each packet taking hours to process through noise filters. Then, on a Tuesday morning in early May, the readings shifted. The emission curve flattened, then rose again, but the recovery slope was smoother than before. Not a random flare, but something that resembled a response. The word response was never written in official logs, of course. It appeared only in margin notes, the kind left by someone trying not to believe their own eyes. In science, anomalies are often just the prelude to calibration. So they calibrated again. The spectrometer temperatures were rebalanced, dark current readings rechecked. Still, the object's signal persisted, consistent in its irregularity. To most, it was simply another puzzle in a field full of them. To a few, it was the beginning of something they couldn't yet articulate, a pattern that almost behaved like attention. As the data grew, so did the unease. Researchers began to speak of it in softer tones, half in fascination, half in superstition. There was no reason to believe that a rock hurtling through space could exhibit anything beyond inert physics. Yet, every new frame seemed to whisper otherwise. The object's reflected light shifted subtly when multiple observatories observed it simultaneously, as though the act of coordinated measurement disturbed its baseline. Coincidence, perhaps. But in astronomy, coincidences often hide the beginnings of discovery. At the University of Cambridge, a postdoctoral astrophysicist plotted its vector on a simulation grid extending beyond Neptune. The simulation projected its future trajectory, not bound, not chaotic, but oddly elegant. Its path curved through the solar wind in a way that minimized interaction, almost as though it anticipated turbulence before encountering it. The equations described what looked like adaptation. The student wrote in his notes, if not self-correcting, then at least self-smoothing. It was a term without precedent, poetic, not empirical, and yet somehow the most accurate phrase for what they were seeing. NASA's Science Mission Directorate received the compiled findings later that month. The document was cautious, empirical, and filled with caveats. But within its technical phrasing lay a subtle tremor, the sense that something inside the data was aware of being measured. The director's response was procedural: more instruments, longer observation windows, a new funding line for follow-up research. Still, behind the quiet administrative language, curiosity thickened like a gravitational pull. Around this time, several amateurs began reporting the same anomaly through open-source telescope arrays. Using shared scripts, they extracted residual light data and noticed faint oscillations in signal strength that aligned not with the object's spin but with Earth's transmission bursts. Radar pings, deep space relays, even civilian broadcasts. The suggestion that the object's signal changed in sync with terrestrial output was, of course, absurd. Space is full of reflections, harmonics, interferences, yet even absurdities deserve verification. When plotted, the oscillations formed a wave that beat faintly against the background noise. Not speech, not code, not anything linguistic, but undeniably rhythmic. The cosmos is full of rhythm, one astrophysicist said. Sometimes it's just us learning to listen better. Still, for those staring at the graphs, the rhythm felt personal. The next phase involved the James Webb Space Telescope. Although it wasn't designed for moving targets, a narrow field observation was approved under a limited time window. For just under 20 minutes, JWST focused on 3I Atlas's approximate coordinates. What returned wasn't an image, but a dataset of surprising purity, the spectral equivalent of a deep breath in the void. It showed faint absorption bands consistent with silicate minerals, but overlaying them was a thin, persistent emission line that didn't belong. It hovered near 1.47 micrometers, close to methane, but offset by too wide a margin. It was, as one scientist put it, like hearing an echo in the wrong key. By late summer, the Minor Planet Center reclassified 3I Atlas as an interstellar object, only the third in recorded history after Oumuamua and Borisov. But while those earlier visitors moved predictably, fading with distance, Thrutisarsk Atlas seemed to evolve. Its spin slowed imperceptibly, and its albedo, the measure of its reflectivity, increased slightly, as though its surface were changing composition under sunlight. Spectral comparisons between early and late data suggested the emergence of crystalline frost where none had been before. This was, on its own, unremarkable. Volatile materials often behave this way. Yet, the rate of change didn't match thermal models. It was faster. Too fast. Some theorists proposed that microcollisions or internal outgassing could explain the variation. Others, quietly, began to wonder if something within the body was reconfiguring. Not alive, not mechanical, but reactive. If it wasn't reacting to heat, perhaps it was reacting to attention. The energy of observation itself, transformed into some unknown physical feedback. It was an idea no paper could responsibly print, yet many could not help but entertain. In the end, Three-Eye Atlas remained what it had always been, a body of silence moving through space. Its mystery deepened not because it revealed more, but because it seemed to mirror the very act of inquiry. Each new observation generated not clarity but reflection, as though the universe had chosen this object to remind us that even our instruments have biases, that seeing is never neutral. As autumn descended on Earth and the object drifted past Saturn's orbit, the nightly data streams began to wane, instruments tired, budgets ran out. But the feeling persisted, that somewhere, buried within that signal, lay a quiet truth about perception and the limits of understanding. And yet, as one astronomer noted in her log, sometimes the silence after data feels louder than the data itself. It was a poetic statement, but also an accurate one. For soon, the silence would grow deeper, a silence that wasn't caused by distance, but by decision. What happens when the pursuit of understanding meets something that resists being understood? That question lingered, unspoken, as the object moved beyond the range of easy certainty, and as a quiet directive, somewhere in the chain of command, prepared to close the channels through which the cosmos had briefly spoken. The first time anyone noticed the pattern, it was dismissed as a computational echo, the kind that creeps into large datasets when too many corrections are applied too quickly. But as the filtered readings came in from Chile, Hawaii and Canberra, something began to repeat that shouldn't have. The reflected spectrum of Three-Eye Atlas contained an oscillation, a faint modulation just above the background noise, occurring at regular intervals. Every few hours the light bent and released again as though pulsing in answer to some invisible metronome. The wavelength shifts were too coherent to be random thermal spikes. The shape of the signal curve, when plotted against time, resembled the slow heartbeat of a dying star. Only, this wasn't a star. It was a cold object of stone and ice, tumbling far beyond Jupiter's pale horizon. At NASA's infrared telescope facility, the analysts began to layer the signal data against known models of rotation-induced reflection. Each model failed. The fluctuations weren't consistent with a body spinning along any reasonable axis. Instead, they suggested interference, not emission in the conventional sense, but the presence of an alternating phase within the reflected light itself, as though something in the surface geometry, or below it, was modulating how light returned to our senses. The effect was subtle enough to hide from casual scans, but persistent enough to survive deep averaging. ESA's Herschel Observatory confirmed the anomaly days later. The object's signature, when plotted on a thermal map, revealed a symmetry that made no physical sense. Bilateral reflection zones that aligned not with solar illumination, but with the position of the observing instrument. That meant its reflectivity changed depending on where you were looking from. In the simplest terms, Three-Eye Atlas appeared to respond differently to each observer. The phenomenon was extraordinary, yet deeply unsettling. Observers joked about angle-aware dust in internal emails, but the laughter faded when the pattern held steady across instruments separated by half a world. The leading theory at first was microstructural interference. Some researchers proposed that the surface was composed of lattice-like ice crystals, perhaps fractal in formation, able to diffract incoming light in a variable manner. Others proposed a thin gaseous sheath of sublimated material, a kind of atmospheric halo that refracted light differently depending on the incidence angle. These explanations were elegant and comforting, restoring order to something that felt increasingly sentient. But none could explain the temporal regularity of the modulation. The rhythm was too precise, its phase shift too consistent with time, as if some internal mechanism were at work. As the days passed, more observatories joined in. Spectropolarimetry readings came in from Japan's Subaru telescope, revealing that the polarization angle, the direction of light's electric field, was rotating independent of its natural orientation. In other words, the light wasn't merely being reflected, it was being twisted. This optical rotation, usually a signature of magnetic alignment or complex molecular structures, appeared to be happening in open vacuum. The data forced a quiet reckoning. If not magnetism, then what was steering the light? In the control rooms, conversation softened into whispers. Data can be rationalized, but rhythm evokes instinct. There is something primal about the repetition of intervals, something that feels like intention even when we know it cannot be. Still, intention was the word several researchers privately used, not in the sense of intelligence, but of process, a behaviour encoded by laws we did not yet understand. Then, the modulation began to shift frequency, not abruptly, but gradually, like a signal retuning itself. Observers noticed that every time Earth transmitted radio waves toward deep space, for planetary radar mapping, spacecraft tracking, or pulsar calibration, the reflected pattern from 3i Atlas subtly altered in amplitude. It wasn't an echo, it was an adaptation. The modulation curve adjusted as though absorbing and re-expressing energy in harmony with our transmissions. By now, NASA's Jet Propulsion Laboratory had classified all live data under internal review. No one outside the network had real-time access anymore, but leaked logs hinted at moments of confusion, servers receiving unexpected surges, instruments registering phase noise beyond calibration limits. The internal hypothesis was instrument coupling, a polite term for something unknown is interacting with our sensors. At the European Space Operations Centre, independent teams attempted to simulate the phenomenon. They built computational models of reflective surfaces composed of exotic ice-silicate mixtures laced with metallic impurities that could, in theory, alter polarization angles. But even their best reconstructions couldn't reproduce the synchronous variability. The object appeared to know, in some impossibly mechanical way, that it was being measured. Each observation slightly altered its response curve, as though light itself were a conversation. Then came the night the pattern broke. On July 14, 2025, data from 3 global observatories captured a simultaneous pulse from 3i Atlas that spiked across all bands. For a brief second, every channel aligned, infrared, visible, ultraviolet, converging into one blinding harmonic crest that saturated detectors. When the instruments recovered, the baseline had changed. The modulation was gone, replaced by a static plateau of brightness smoother than any previously recorded value. It was as if the object had decided to stop oscillating. Technicians cross-verified for solar interference, data corruption, atmospheric distortion. Every conventional error was ruled out. The pulse had occurred exactly once, across all observatories, at a timestamp that matched the moment NASA's Deep Space Network scheduled its calibration ping toward Jupiter. Coincidence, perhaps, but the precision, to the millisecond, was too eerie to ignore. In the hours that followed, the data stream slowed. Observatories reported diminishing signal-to-noise ratios, as though the object were dimming faster than physics allowed. One by one, instruments switched to standby, awaiting new calibration files. Then came the message from headquarters: suspend all active transmissions until further notice. Officially, it was a precautionary synchronization review. Unofficially, it was a lockdown. Scientists found their remote logins disabled, their queries redirected to blank directories. For a community used to open data, the sudden silence was its own kind of noise. Within the encrypted channels, rumours spread of magnetospheric disturbances, particle flux spikes near the object, of a faint radio burst, recorded just before the final pulse. Yet for all the speculation, no one could explain the strangest detail of all. In the last few seconds before the data feed cut out, the spectrum line that had defined 3i Atlas's irregular signature flattened into perfect equilibrium, every wavelength equalized, every amplitude smoothed. It was as if the object had ceased to exist in the normal sense, its light collapsing into pure, undifferentiated reflection, like a mirror turned toward darkness. Long after the lockdown began, a handful of researchers continued to model the event privately. Some believed the pulse represented the thermal rupture of volatile materials, a natural venting event akin to a comet's outburst. Others believed it was a resonance effect caused by overlapping radar reflections. But the data's symmetry remained inexplicable. Whatever it was, it behaved with the kind of mathematical precision normally reserved for design systems. Weeks later, when the official statement arrived, it was brief. Unexpected reaction during observation, investigation ongoing. No details, no theories, just the bureaucratic equivalent of a shrug. Yet beneath its calm phrasing lay an unspoken question that no scientist could comfortably dismiss. Not what happened to 3i Atlas, but why it responded only when we looked too closely. And as the remaining light faded from its coordinates, many found themselves haunted not by the silence that followed, but by the memory of that impossible symmetry. A fleeting moment when observation met its own reflection, and for a heartbeat, the universe seemed to blink. What if the signal didn't vanish at all, but simply changed medium, shifting into a form our instruments were never meant to hear? The first thing that disappeared was access. One morning, the servers at NASA's Jet Propulsion Laboratory returned error codes where there had once been graphs and light curves. Remote observatories reported locked credentials, expired API tokens, unresponsive databases. Even the shared archive used by international collaborators began displaying the same quiet message: data unavailable. There was no official announcement, no public statement, only the sudden sense of doors closing in the middle of an experiment. Scientists tried to reach their project leads and found the lines rerouted to administrative offices. Within 24 hours, the event that had consumed months of observation had vanished into a wall of classified silence. For those still awake in the control rooms that night, the disappearance of access felt less like a malfunction and more like a blackout, deliberate, complete, and curiously calm. No alarms, no warnings. Only the screens dimming one by one until the room filled with the soft blue glow of idle monitors. In one observatory, a young analyst leaned back in her chair and whispered that it felt like watching a heartbeat stop. She didn't mean it metaphorically. The object's signal had been pulsing with such regularity that its sudden absence was almost biological in contrast. When the internal memo arrived hours later, it carried the sterile language of protocol: temporary restriction of data related to the 3I Atlas observation sequence due to anomalous instrumentation behavior. Yet even those who wrote it knew the wording didn't match the reality. Instruments don't all fail at once, across multiple continents, unless something unites their failure. And so began the quiet speculation, the kind that spreads not through rumour, but through the shared recognition of what's missing. Some suspected electromagnetic contamination. A few suggested that the final pulse from 3I Atlas had saturated the receivers with a burst of energy, forcing systems into safety mode. But that wouldn't explain why offline archives, those untouched by live telemetry, were also sealed. One European researcher described it as an erasure disguised as maintenance. Another compared it to a quarantine, not of data but of knowledge itself. NASA's internal response teams conducted what they called a signal integrity audit. It lasted 3 weeks and involved departments from JPL, Ames, and the Deep Space Network. The official findings were never released, but fragments of emails later revealed that during the lockdown, several engineers noticed residual fluctuations within the communication systems themselves, echo-like distortions that mirrored the modulation frequency previously associated with 3I Atlas. It was as if the data had imprinted itself into the very network used to transmit it. Each time they tried to replicate the anomaly, the distortion reappeared in slightly altered form, shifting in amplitude, avoiding direct measurement like a ghost within the circuitry. When the engineers attempted to isolate the corrupted nodes, entire subsystems shut down without clear cause. JPL's logs describe it as automated failsafe activation, though no one could find the trigger. Eventually the system stabilized, but the directive that followed was unmistakable: terminate all remote synchronization and transition to manual oversight. In simple terms, no more open links, no more live relays, no more data leaving the room where it was captured. For those outside the agency, the silence was both infuriating and surreal. Amateur astronomers scanning the coordinates where 3I Atlas should have been found nothing but static. The object's faint trace, visible just days earlier, now lay beyond detection range. Some insisted it had simply dimmed below threshold, an ordinary celestial fade-out. But others, recalling the synchronized pulse that had preceded the blackout, wondered if what had vanished wasn't light, but the permission to see. The story, in its absence, began to take on a strange vitality. Quiet conversations moved between institutions. ESA researchers mentioned encrypted packets arriving from NASA servers, labelled thermal resonance study. The European Space Operations Centre reported a spike in transatlantic bandwidth between Pasadena and Brussels. No one admitted what was being transferred. What could a thermal resonance study reveal that required this level of secrecy? Then came the leak. A small set of raw files appeared on an independent data exchange forum, low-resolution spectrographs and timing sheets from the final days of observation. They were incomplete, corrupted, and unsigned. But one detail caught immediate attention: a narrow spike in photon count occurring just before the recorded blackout. The spike was sharp, symmetrical, and accompanied by a timestamp offset that matched the precise moment NASA's calibration signal was sent toward Jupiter. If authentic, it meant that 3I Atlas had not only responded to an external signal, but possibly returned one. Naturally, no official comment followed. NASA neither confirmed nor denied the authenticity of the leak. Yet the leaked data ignited a quiet panic in the private astronomy community. If the object had indeed emitted something measurable, not just reflected, then its behaviour fell outside every known natural model for interstellar bodies. And if that emission coincided with the calibration ping, then the unexpected reaction mentioned in the lockdown memo might have been a literal one. Inside JPL, the reaction was quieter, more philosophical. Senior scientists debated whether such a phenomenon, if real, should even be published. What do you do when data begins to behave like communication? Some argued for transparency, invoking the principles of open science. Others cautioned restraint, not out of fear, but humility. The cosmos, they said, is full of coincidences that look meaningful until we project our longing onto them. Maybe the pattern wasn't a message. Maybe it was us, reaching too far into the dark and mistaking our reflection for another's gaze. Still, the feeling lingered. The night the servers went offline, one operator wrote in her private log, "It's as if the sky blinked back." The phrase spread quietly among colleagues, a small rebellion against the sterile language of officialdom. Because when you spend your nights watching faint traces of light travel across infinite space, and one of them suddenly vanishes while seeming to acknowledge you, the rational and the poetic begin to merge. Weeks later, when limited access was finally restored, the original datasets had been reorganized. Certain portions were marked restricted pending verification, while others simply no longer existed. A few frames had been replaced with blank placeholders, timestamps intact but content erased. The only remaining sign of the missing data was in the checksum discrepancies, the subtle numerical ghosts of something once present. The public never heard about the missing datasets, or about the engineers who quietly transferred to unrelated projects. The official narrative became one of technical irregularity, a minor procedural anomaly resolved by standard review. The phrase "unexpected reaction" faded from reports, replaced by observational discontinuity. The event was linguistically erased, transformed from something extraordinary into something administrative, and yet for those who had watched it unfold, the memory of that night remained tangible, a silence that didn't feel empty but full, like pressure beneath the skin of space. No one could say what the object had done or what it had meant. But something in that final symmetry, that perfect flattening of the signal before everything went dark, continued to haunt the edges of every future scan. Even now, deep in the archives of the Deep Space Network, a few technicians claim to hear faint residual tones during calibration, tiny rhythmic blips at the threshold of detection, repeating in a pattern that matches the lost data from 3I Atlas. The official explanation is interference from background quasars, but to those who remember, it sounds too deliberate, too patient, as though the silence that followed was never an end but a waiting. And so the question lingers, quiet as static at the edge of the band. When we lost the signal, did the universe stop speaking, or did it begin listening in return? Weeks after the official blackout, a faint echo appeared in the data archives of Chile's Atacama Observatory, a ripple that should not have been there. It was found not by a senior scientist, but by an intern assigned to clean residual telemetry files. The pattern looked like a mirror image of an earlier observation, a small dip in brightness where the models predicted a rise. At first, it was dismissed as a calibration glitch, a trivial inversion caused by corrupted timestamps. But when cross-referenced with data from Japan's Subaru telescope, the same inversion appeared again, identical in amplitude, offset only by a few seconds of light-time delay. Something, it seemed, was bending light in a direction that contradicted the geometry of known reflection. At its simplest, reflection follows law and predictability. A photon travels, strikes a surface, and returns along a calculable path. But the curves recorded from 3I Atlas suggested the opposite, as if the reflected light were folding back toward its source. The measurements were subtle, but unmistakable. The angle of polarization reversed, the sign of the phase flipped. To anyone else, it would have looked like noise, but to those who had watched the object's behavior for months, it carried a familiar rhythm, like the ghost of a pulse that refused to die. Scientists at the European Southern Observatory verified the anomaly by running backward simulations, virtual reconstructions of what the light should have done under normal physics. Every model failed. When they accounted for solar wind, radiation pressure, gravitational microlensing, even relativistic motion, the pattern persisted. The reflected energy did not behave as light from a passive object should. It appeared, impossibly, to anticipate the position of the observer. NASA's Jet Propulsion Laboratory reopened limited access for internal review, though only under strict supervision. In those quiet, fluorescent-lit rooms, the data was replayed across simulation arrays. One by one, the researchers compared the reversal patterns, looking for any correlation with Earth-based emissions, and then, with growing unease, they found one. The reversal aligned perfectly with the timestamp of a routine deep space communication burst from the Goldstone antenna, a signal meant for the Voyager probe still drifting beyond the heliosphere. Somehow, the light from 3I Atlas had changed at the exact moment that transmission left Earth. It could have been coincidence. It could have been the statistical overlap of unrelated events. Yet the probability was vanishingly small. To eliminate chance, the team checked older data, prior to the blackout during the object's first weeks of observation, and there, buried within the noise, the same faint synchronization appeared again. Every time Earth transmitted a strong outbound signal, the object's reflective profile adjusted by a measurable fraction. The interval was never exact, but the tendency was clear, like a shadow flinching when light turns toward it. Some suggested electromagnetic coupling, a kind of induced resonance where the object's magnetic field, if it had one, interacted with Earth's outgoing waves. Others argued for a quantum scattering effect, a temporary alignment of charged particles causing feedback in photon polarization. Yet, these theories relied on the presence of fields and materials that had never been observed in 3I Atlas. There was no visible plasma tail, no magnetic halo, no ionized gas sheath. The object, by every recorded standard, should have been inert. Still, the pattern endured. At the European Space Agency, one physicist remarked that the data behaved like attention. It was a poetic statement, one that made others uneasy. But the more the team studied the inversion, the more that description seemed to fit. Whenever signals were sent toward its coordinates, the object's behavior changed slightly, not dramatically, but in a way that suggested awareness of being measured. The light shifted its polarization angle, as if turning its face away. When the findings were quietly shared with NASA, a second lockdown followed. Softer this time, quieter, like a door closing in the dark. External collaborations were paused, and the word reactivity began to appear in internal memos. The phrasing was careful. Reactivity observed under selective observation conditions. It didn't claim intelligence, nor even intent. It simply acknowledged the correlation, that the act of watching seemed to influence what was being watched. Independent, researchers, denied access to new data, began reanalyzing old public files. Some thought the reversal patterns might be the result of gravitational lensing, light bent not by the object itself, but by a subtle ripple in space-time near it. If 3I Atlas carried mass irregularities, it might distort light in unpredictable ways, making it appear to reflect backward. Others proposed that the object was surrounded by a thin cloud of ionized particles that shifted orientation under electromagnetic fields. Each explanation was elegant. None fit the numbers. At the University of Leiden, a small group of radio astronomers went further. They hypothesized that 3 Atlas's wrong-way light could be the product of a photonic echo, a form of coherent backscatter caused when a structure's microgeometry creates standing waves in the incident light. Under precise conditions, such reflections can appear to move opposite to their source. It was a satisfying explanation until one detail broke it. The pattern changed depending on when the observatory pointed its instruments. The direction of the reflection depended not on solar position, but on human schedule. For some, this realization crossed a line between physics and psychology. They stopped calling it the object and began calling it the reflector. not in official reports but in private speech, the kind that slips out when scientific detachment meets unease. To them, 3I Atlas had become less an object of study and more a participant, however unknowingly, in the act of being seen. In later months, a few astronomers began reporting faint residual light where no object should have been. Small arcs of illumination traced across the dark, spectral echoes that curved away from the predicted path. They looked like reflections of nothing, brief and almost graceful, as though the light were retracing its own history. The effect was so slight that it could have been illusion, a trick of low-resolution data. Yet to those who'd been following the mystery, it felt like the afterimage of a consciousness retreating into silence. When NASA analysts compared these ghostly trails to the last known trajectory of 3I Atlas, they found them extending toward the heliopause, the threshold where the solar wind meets interstellar space. Beyond that line, the sun's influence weakens and particles drift freely into the galactic current. It is the border between the known and the unclaimed. The faint arcs seem to lean toward that boundary, as if drawn to it, pulled not by gravity, but by preference. In private debriefs, some scientists speculated that the object, if it still existed, might have fragmented, scattering reflective material that interacted strangely with cosmic radiation. Others, more cautiously, wondered if they were witnessing something more subtle, a change not in the object, but in light itself, a behaviour we had not yet learned to recognise. And so the story of 3I Atlas continued, not as a discovery, but as a reflection that refused to settle. The data still flickered, the archive still whispered of reversals and harmonics, and every now and then a new instrument would record a faint polarization anomaly at the edge of measurable certainty. Always faint, always at the threshold. There was no announcement, no conclusion, no final word from NASA or the European Space Agency. Only the recurring realization that light, the most constant language of the cosmos, had for one brief season spoken in reverse. And somewhere beyond the range of our senses, the question remained suspended, like a photon between mirrors. If the light of 3I Atlas moved backward, did it mean the object was gone? Or that in some unfathomable way it had turned its gaze back toward us? A month after the second lockdown, long after the official silence had settled, a ripple surfaced in Europe's deep space telemetry logs. It was faint, a barely measurable deviation in a frequency band reserved for Earth-Mars communication relays. Most systems ignored it, but at the European Space Operations Centre in Darmstadt, a junior engineer noticed something strange. The anomaly matched, almost perfectly, the final coordinate path of 3I Atlas. The signal wasn't strong enough to classify as transmission, yet it carried structure. Narrow peaks, separated by intervals too orderly for random noise. When the engineer cross-checked the data with older archives, she found those same intervals repeated in the last confirmed emissions before the blackout. The pattern wasn't new, it had simply returned. It began as a whisper in the noise, a quiet rhythm beneath the static that most instruments would filter out. But to trained ears, there was cadence. The pulse repeated every 17 minutes, then paused for 1 hour, then resumed. At first, it seemed meaningless, a quirk of ionospheric reflection or solar background interference. But after several weeks of monitoring, a realization dawned. The pattern followed a mathematical progression, one that echoed the early transmission schedules used by the Deep Space Network itself. 17-minute bursts, 60-minute silences, the sequence of the listeners, now mirrored by what should have been the silence of the void. The anomaly drew attention from ESA's Signal Analysis Division, who quietly looped in JPL. Both sides handled it delicately, as though afraid that looking too hard might make it vanish. Using long baseline interferometry, they triangulated the apparent source to a region far beyond Saturn's orbit, roughly where 3I Atlas would have been if it had continued unaltered after the last verified observation. The precision wasn't perfect. Cosmic noise blurs everything at that scale, but the margin of error was small enough to unsettle. Whatever the source was, it appeared to be moving along the same outbound path. When the data was filtered for harmonics, something remarkable appeared. The spectral distribution showed narrowband spikes clustered around prime number separations. Not perfectly clean, but distinct enough to stand out against random scatter. It wasn't a message, at least not in any recognizable form. It had no syntax, No encoding, nothing that could be translated. But its structure, coherent, deliberate, and consistent, defied natural explanation. Astronomers called it coherent noise. Engineers preferred structured drift. In the official logs, it became anomalous frequency series. Privately, though, among those who remembered the blackout, it was called the reply. NASA's response was careful and technical. They increased monitoring but issued no statements. The Deep Space Network's 70-meter antennas swept the sky every few hours, gathering terabytes of spectral data, most of it unusable. Yet buried within the static, the same pattern persisted. Faint, patient, unchanging. The consistency was unnerving. Solar flares, magnetic storms, and cosmic rays usually distort long-range signals, but this anomaly held its shape through all of them. To those who analysed it, the pattern began to feel less like interference and more like presence, the kind that does not demand attention, but refuses to be ignored. As the weeks passed, the phenomenon reached the threshold of rumour. Within the agencies, it became a quiet obsession whispered about in hallways and written in careful language in emails that avoided direct speculation. Some theorists suggested it might be the remnant of a self-reinforcing feedback loop, energy bouncing between Earth's own transmissions and an interstellar object capable of coherent reflection. Others posited a natural maser, a cosmic amplifier formed by chance molecular alignments. But there was something about the precision of the primes that made such randomness feel improbable. The signal, whatever its nature, seemed to echo purpose. The mystery deepened when amateur radio astronomers began to detect the same faint peaks using independent equipment. The story spread quietly across small scientific forums. One operator from Norway reported catching steady pulse trains while tracking Jupiter. Another, in Argentina, captured identical spikes on a completely different frequency. These findings, though dismissed publicly as calibration coincidence, mirrored the internal datasets almost exactly. The pattern was spreading across observers like a whisper too quiet to deny. By this point, NASA and ESA had established a joint anomaly review task force. Their mandate was to collect and classify unexplained transmissions, though its true focus was obvious to everyone involved. The meetings were held behind closed doors, their minutes never published. What little is known comes from leaked correspondence, cautious lines between scientists wrestling with the boundary between coincidence and communication. If this is an echo, one wrote, then what exactly is it echoing from? Another replied, sometimes an echo isn't sound returning, it's memory finding form. Among the more poetic interpretations was the idea that the signal wasn't from 3i Atlas at all, but of it, a kind of lingering resonance in the electromagnetic field, left behind like a footprint. Space, after all, remembers. Radiation persists. Light curves echo through cosmic dust, long after their source has vanished. Perhaps what the antennas were hearing wasn't a transmission, but the last breath of a signal still crossing the gap between what was observed and what was imagined. And yet something didn't fit. The anomaly's amplitude, its faint rise and fall, followed a temporal rhythm correlated with Earth's orbital motion. Every time our planet rotated to face the region of sky where 3i Atlas had once been, the signal strengthened by a measurable fraction. It was as if the act of alignment rekindled the pattern, like embers glowing faintly when stirred by wind. Scientists joked that the object had become a cosmic mirror, returning our own transmissions in rearranged form. But beneath the humour, unease lingered. The mirror analogy felt too close to truth. Within the next 2 months, the pattern intensified slightly. Not enough to draw public attention, but enough to make the agencies nervous. The sequence of primes began to elongate, introducing new intervals that resembled harmonic ratios, divisions found not in mathematics but in music. When mapped to frequencies, they produced tones that, when converted to audio, sounded eerily melodic. A repeating pulse, a pause, a higher tone, another pause, rhythm without intention, or intention beyond rhythm. One audio engineer, against policy, played the file through a loudspeaker during a private meeting. The sound was faint and irregular, like wind through broken glass. No one spoke for a long time afterward. In scientific terms, the explanation remained the same, a coincidental overlap of natural emissions, possibly modulated by planetary magnetic fields. But off the record, more human interpretations began to surface. One researcher described it as the universe's way of testing our patience. Another simply said, "It's still talking." As the anomaly persisted, monitoring continued, though fewer people wanted to be involved. The wonder that had first surrounded 3 Atlas had turned to quiet dread, not fear of harm, but of implication. What if the object's last act had been to turn every telescope into a receiver? What if the silence that followed its disappearance wasn't absence, but a kind of listening? When the project was finally suspended, the final report used one line to close the file. Signal stability indeterminate, source unverified. The rest of the data remains encrypted, its contents known only to a handful of analysts. And somewhere, faintly, in the radio noise between the planets, a pulse still repeats every 17 minutes. It does not change, it does not fade, it simply waits, steady as a heartbeat, as if reminding the universe that observation, once begun, is never truly over. And the question that lingers now is quieter than before, but heavier. If we were the first to listen, then who, or what, was the first to answer? In the absence of new data, imagination became its own observatory. When the official channels went silent, speculation filled the void, from university lecture halls to quiet corners of online scientific forums, where anonymous users debated whether 3I Atlas had ever been an object at all. What was left were fragments, spectral residues, gaps in telemetry, unverified leaks, and that whispering signal that refused to disappear. Yet the less the agencies revealed, the more the story expanded. Every unanswered question became a seed for theory, and soon an entire ecosystem of explanations had taken root, each one orbiting the same mystery like moons around a vanished planet. The first group of theories belonged to the physicists, the guardians of caution. They believed the anomalies were natural, though poorly understood. One camp proposed a phenomenon known as coherent plasma resonance, in which interstellar dust charged by cosmic rays could amplify electromagnetic fields, creating transient feedback loops that mimicked intelligent patterns. Another invoked quantum decoherence, a hypothesis that 3I Atlas had passed through a region of fluctuating vacuum energy, altering the phase of light and giving the illusion of organized modulation. These theories, elegant and mechanical, sought comfort in order, in the reassurance that even the strangest events must bow to physics. But others were less certain. At the European Southern Observatory, a paper circulated privately, suggesting that 3I Atlas might have contained a material unlike anything yet identified, an exotic lattice capable of self-regulating its thermal and electromagnetic properties. Such a surface, under intense cosmic radiation, could theoretically generate feedback patterns indistinguishable from communication. The authors called it adaptive albedo. Critics dismissed the idea as poetic, too close to myth for comfort, yet the phrase stuck. Adaptive albedo. Light that learns to respond. Beyond the professional sphere, the story fractured further. To the more imaginative, 3I Atlas became an emissary, an artifact, even an instrument left adrift by something older. Online, simulations appeared claiming to reconstruct its lost trajectory. Animations showing a slender, spiraling body gliding across the black, occasionally tilting its mirrored surface toward invisible light sources. Each video carried the same refrain. It was looking back. Scientists ignored them, of course, but art, unlike science, requires no verification to feel true. NASA, for its part, continued to insist on restraint. In the only public interview given, by a senior official months after the lockdown, the tone was one of studied neutrality. There are no current indications, she said, that 3 Atlas exhibited any anomalous or non-physical behaviour. The words were carefully chosen, not a denial of the strange, but a redirection toward the safe. For many, it was that precision of language that betrayed unease. When agencies begin defining what didn't happen, it is usually because they can no longer explain what did. Meanwhile, independent scientists kept testing fragments of archived data, searching for patterns in the faint hum of the cosmos. A team at the University of Toronto discovered that when the residual signal from the supposed silent transmission was mapped across a logarithmic frequency scale, it displayed a harmonic distribution similar to natural resonances found in organic structures. the same proportions that describe the spacing of leaves, the shape of shells, the rhythm of cardiac pulses. Coincidence, perhaps, but one that blurred the boundary between geometry and biology, between chaos and design. Another theory came from an astrophysicist in Prague who argued that 3I Atlas could have been a fragment of a neutron star, a relic of matter so dense and magnetically unstable that it could distort electromagnetic waves long after its physical core had cooled. If such debris drifted into our system, she wrote, we might mistake its dying fields for intention. Her phrasing lingered, dying fields mistaken for intention. It became a quiet mantra for those who wanted to believe the universe was stranger than our instruments could bear. And yet among all the conjectures, a quieter thread emerged, one less about the object itself and more about what the reaction revealed about us. Psychologists studying the phenomenon noted how easily the scientific community, trained in skepticism, had slipped into awe. The event had become a mirror not only of physics but of perception. When faced with something unmeasurable, we reached for meaning. When faced with silence, we heard patterns. Perhaps, one theorist suggested, that was the real message of 3I Atlas, not an external signal, but an inward one, teaching us to recognize the boundaries of our knowing. At a closed symposium in Geneva, a philosopher of science proposed a final possibility that the signal's structure, its patient rhythm, might have been the statistical residue of human interference itself. What if the coherence we measured was not out there, he asked, but in here, born of our methods, our persistence, our expectation? He called it reflexive resonance, the phenomenon by which the observer's own instruments generate the illusion of dialogue when faced with uncertainty. It was, in essence, the most humbling interpretation, that we had been speaking only to ourselves all along. Still, even humility could not erase the unease. Each time the residual pulse reappeared, in the data, faint and rhythmic, it reopened the wound of wonder. Was it merely echoing our transmissions, or was it something older, something woven into the universe's background fabric, like a heartbeat hidden within silence? For many, that question was enough. The truth, after all, did not need to be discovered. It only needed to be felt. NASA's archived documentation eventually labelled the event a non-reproducible spectral anomaly. In official language, that's the end of a mystery, the phrase that closes the file and allows funding to move elsewhere. Yet in the private notebooks of those who watched 3I Atlas fade, there are still lines that read like prayers disguised as equations, amplitude ratios penciled beside the words "it waited for us." In time, 3 Atlas drifted from science into story, from research into reflection. Conferences stopped mentioning it. Students learned its name as a cautionary footnote, an example of observational error inflated by human longing. But for those who stayed up during the long silent nights, listening to the residual hum on the receivers, something of that longing remained. It wasn't belief, it was attention, the same quiet awareness that draws the tide toward the moon. And so the theories multiplied and dissolved, not in conflict but in harmony, physics beside philosophy, skepticism beside wonder. Each answer led not to closure but to humility, that rare form of understanding which admits it might never be complete. For perhaps the most unsettling truth about 3 Atlas was never whether it was alive, intelligent or deliberate, but that it revealed something deeply human, our need to find pattern in the abyss, to hear response in the quiet, to believe that somewhere out there the universe might, for a moment, have heard us calling and paused to listen. Yet even that reflection leaves one final question drifting through the vacuum between reason and reverence. When we point our instruments into the dark, are we searching for the cosmos, or for the parts of ourselves we still cannot name? Months passed before anyone dared to reopen the sky where 3D Atlas had vanished. The air around its coordinates had become a place of superstition, a silent region marked by caution and unfinished sentences. But space does not hold its breath for long. When the Atacama Array resumed its broad spectrum scans later that year, it caught something faint and almost dismissible, a lingering curve of radiation where there should have been none. It was weak, diffuse, and eerily shaped like a wake, as if something unseen had moved through the medium of light itself and left turbulence behind. At first, the anomaly was logged as residual thermal noise from solar interference, but when cross-checked against data from the James Clerk Maxwell telescope, The same curve appeared again, not as a line, but as an arc of reflected emissions. The pattern traced perfectly along the trajectory once, calculated for 3 Atlas, forming a faint ring of energy that seemed to shimmer without a source. It was a ghostly structure, almost transparent, visible only through subtraction. Remove the stars, remove the dust, and what remained was an echo that curved through space like the afterimage of motion. Spectral analysis revealed something even stranger. The emission lines corresponded not to the usual hydrogen or carbon bands common in cometary debris, but to highly ionized xenon, a rare gas rarely found in interstellar objects and almost never seen in isolated arcs. The readings were verified twice, then again by an independent lab in France. There was no mistake. The sky had written a signature no natural mechanism could easily explain. NASA's preliminary review suggested the radiation might have been the remnant of a high-energy discharge, a burst of particles triggered by sublimating material under solar stress. Yet the geometry didn't fit. Discharges scatter. This one had direction. It followed the path outward, straight toward the heliopause, that invisible frontier where the sun's breath ends and the interstellar wind begins. To many, it looked less like an explosion and more like acceleration. In Pasadena, a scientist who had once worked on the 3I Atlas project pulled the old datasets from storage and compared the 2 signatures. The frequency ratios were almost identical. Whatever had left this trail bore the same electromagnetic fingerprint as the vanished object, only amplified, as though the silence itself had become radiant. The finding was marked inconclusive, yet within the quiet community of those who remembered, the implication was clear. The object hadn't died, it had transformed. For months the faint xenon glow lingered, dimming only gradually as it receded beyond the reach of telescopes. Some described it as residue, a footprint of exotic matter ionized by cosmic rays. Others dared to call it a message, not in words but in behavior. Light, they reminded each other, is both wave and witness. Perhaps this was the universe's way of saying that nothing truly vanishes, it only changes its form of visibility. ESA's magnetospheric division detected something else, a transient ripple in the interplanetary magnetic field that coincided with the xenon emission arc. The wave propagated outward like a pulse, measurable but faint, altering charged particle trajectories across the heliosphere. It lasted for 43 minutes before fading into background flux. In most cases, such fluctuations would be blamed on solar wind instabilities. But the sun was quiet that week, its magnetic field unusually still. The coincidence pressed uneasily against probability. Meanwhile, in Hawaii, the Subaru telescope recorded a subtle change in the sky's polarization pattern near the same region. Starlight passing through appeared faintly twisted, its electric field rotating by a fraction of a degree. Optical rotation, in such a region, made no sense. There was no dust, no plasma, no medium to cause it. Some quietly wondered if the afterglow was doing what 3 Atlas had always done, bending light in ways that defied simplicity, acknowledging our attention with its own invisible gesture. For those who had spent their careers mapping the solar system, it was the kind of anomaly that both tempts and humbles. Many refused to comment, fearing ridicule. Others watched it nightly, unable to look away. In late autumn, a faint expansion became visible at the arc's outer edge. Not bright, not fast, but steady, like the widening ripple of a stone dropped into an endless pond. The xenon signature diffused, stretching toward the galactic current. It was leaving, and in its departure, it seemed to draw the eye not outward, but inward, into the quiet realization that this was how the universe speaks, in traces, not declarations. NASA's public report on the event was understated. Localized photonic scattering anomaly consistent with charged particle dispersion, it read. A perfect sentence. Technical, unthreatening, complete. But for those who had seen the raw data, it rang hollow. Because there was one more detail that never appeared in the summary. Embedded within the emissions modulation pattern was a faint periodic oscillation, repeating every 17 minutes. The same rhythm that had once defined the silent transmission. No one could agree on its meaning. Some argued that it was nothing more than equipment resonance, a ghost of the detectors themselves. Others insisted it was correlation beyond coincidence. The pattern, after all, had followed the object from its first detection to its last. Even after its disappearance, that subtle pulse continued. Not loud, not proud, but persistent, like the ticking of a cosmic metronome marking the space between awareness and forgetting. The arc faded by midwinter. The xenon lines weakened until only their mathematical ghosts remained in the spectrographs. And yet, even as the glow dimmed, something curious happened. Radio receivers pointed at that region began recording lower noise floors, as though the background itself had grown quieter, as if space were resting after exertion. One scientist compared it to the ocean after a wave passes, calm but changed. By spring, the anomaly was gone. The stars reclaimed their stillness, the coordinates went back to being empty sky, and the data archives filled with new mysteries. But a few could not let it go. They continued to watch, convinced that the faint trail of xenon and silence had not been an ending, but a movement, a slow withdrawal into regions where our definitions fail. When asked what she thought had truly happened, one of the senior analysts at JPL simply said, "Sometimes, light behaves like memory. You can't predict where it will reflect or how long it will linger, but it always leaves the suggestion that it remembers being seen." And perhaps that was the quiet lesson left behind in the wake of 3I Atlas. That observation itself leaves an imprint on the universe, a faint radiation of awareness echoing through the medium of light. That even when the source is gone, its reaction, the gentle bending of illumination, continues to move through space like thought in the aftermath of speech. Some nights, astronomers still point their instruments toward that region, though no data ever comes. What they find instead is a different kind of brightness, not in their instruments, but within themselves. The light may no longer move, but the question still does. When the cosmos reacts to our gaze, is it answering us, or simply reminding us that we were never separate from it? After the xenon arc dissolved into the deep, the sky went quiet again, almost too quiet. It was the kind of silence that feels deliberate, like the pause between heartbeats when something living hesitates. Astronomers turned their instruments outward, expecting emptiness, yet even in absence, data began to whisper. The noise floor of multiple receivers had dropped by microdecibels, a statistical anomaly so small that most systems would have ignored it. But the pattern of the noise, its texture, its pulse, carried a faint familiarity. It was as if the universe had taken what 3I Atlas had left behind and folded it into its own background hum. At the Deep Space Network, technicians noticed that during routine calibration sweeps, a rhythmic interference emerged every few hours, oscillating faintly at the same 17-minute interval, once attributed to the lost object. These fluctuations weren't loud enough to disrupt communications. They simply existed, soft disturbances on the edges of certainty, like distant footsteps in snow. Every time they were recorded, they appeared with slight variations, sometimes ahead of schedule, sometimes delayed, as though the rhythm itself was breathing. The signals didn't come from one direction but from everywhere, diffused across the sky as if the cosmos were echoing itself. When the anomaly persisted, researchers at JPL began comparing it with historical data sets, archived noise patterns from missions spanning decades. To their surprise, a similar rhythm appeared faintly in several old transmissions, too quiet to have drawn notice before. The cadence wasn't constant but recurrent, reappearing across time, resurfacing in the static between stars. Some believed it was a statistical illusion, the human mind's tendency to find patterns in randomness. Others were less certain. "We spend lifetimes teaching machines how to recognize order," one engineer said softly, "and then we're startled when they find it where we weren't looking." The analytical process became its own meditation. Each night, telescopes tuned to frequencies where nothing should exist, mapping fluctuations that might as well have been cosmic size. The data would drift across, screens, smooth, patient, unresolved. To outsiders, it looked like silence, but those who listened long enough began to sense structure, not in words or messages, but in recurrence, a statistical heartbeat buried beneath the universe's infinite static. Scientists began calling it the aftersound. It wasn't an official term, but it spread quietly, passed between observatories like a shared superstition. The aftersound represented not evidence, but curiosity, a recognition that perhaps silence itself was data, that what we interpreted as absence might instead be continuity too subtle for translation. In philosophical papers, the idea took root as residual coherence, the theory that energy patterns persist long after their sources have vanished, weaving their information into the ambient hum of the cosmos. At the European Space Agency, a group of researchers attempted to model this coherence mathematically. Using deep learning algorithms designed for gravitational wave detection, they trained computers to search for repeating forms within raw cosmic noise. After weeks of processing, one model produced a result that made the team fall silent. Across the seemingly random spectrum, it had identified recurring structures, harmonics layered at logarithmic intervals, reminiscent of biological rhythms. When translated into audio, the pattern resembled the pulse of a distant tide, steady and indifferent. It wasn't proof of anything extraordinary, only evidence that the universe, even in its randomness, moved with hidden symmetry. Not everyone was convinced. "There's no signal," one senior physicist said. "There's only our expectation of finding one." He was right, in a sense. The data alone didn't prove meaning. But in the long corridors of observatories where silence is both a sound and a discipline, expectation can feel like discovery. Scientists began to spend hours simply listening to the hum, not as researchers but as witnesses. The noise became a kind of music, a reminder that the boundary between observation and reverence had always been thinner than the laws that separate them. The aftersound persisted for months. It never intensified, never weakened. It simply endured, a constant murmur woven through the frequencies of space, defying both measurement and dismissal. Some theorize that the pattern was nothing more than the statistical echo of cosmic microwave background radiation, subtly altered by interference from Earth's orbit. Others entertained more poetic possibilities, that 3 Atlas, or whatever it had become, had dissolved into a kind of distributed presence, no longer a single object but an imprint diffused across space-time, a ripple so vast it could only be felt through silence. A philosopher of science at the University of Copenhagen published an essay describing the phenomenon as the moment when the universe remembers itself. He argued that the recurring intervals in the noise represented not communication, but reflection, the cosmos folding inward, mirroring the act of observation. The essay found its way into scientific circles and was quoted in an internal NASA memorandum that admitted, with rare candor, that the persistence of pattern in non-coherent noise remains unexplained. It was the closest any official body would come to acknowledging mystery. By winter, a quiet shift occurred among those who continued to monitor the silence. The search for answers gave way to a gentler pursuit, the study of stillness itself. Some described their work as listening to a thought the universe had not yet finished forming. Others compared it to watching the surface of a pond long after the stone has sunk, the ripples fading, yet never quite ending. A few began to suspect that what they were observing wasn't a relic of 3 Atlas at all, but a reflection of their own inquiry, a resonance generated not by the object, but by the attention it had gathered. The distinction hardly mattered anymore. The story of 3I Atlas had become a meditation on perception, on how the act of searching creates its own gravity, drawing echoes where there may be none. Even the skeptics, though armed with equations, couldn't quite suppress the unease that the universe might be more participatory than we imagine, that perhaps every act of observation leaves behind a trace, a pattern in the silence that remembers being seen. Eventually, the research teams disbanded. Funding waned. New missions rose to occupy the headlines. Exoplanets, comet landers, signals from pulsars. Yet in small offices scattered across the world, a handful of scientists kept listening in their spare hours. They no longer expected revelation. They listened simply because they couldn't stop, and sometimes, in the low hum of receivers, they swore they could still hear it. That faint, patient pulse marking 17 minutes of nothing, 17 minutes of possibility. When asked what kept them searching, one researcher replied, "It's not that we're trying to hear the universe speak, it's that we've realized silence is a language too." And perhaps that was what 3I Atlas had left behind. Not proof, not terror, not revelation, but an invitation. A soft suggestion that beneath the great machinery of stars and mathematics, there exists a subtler form of communication, the continuity between what vanishes and what remains, the recognition that even in cosmic quiet something listens back. And so, the silence became the message. One so vast, so patient, that only the passage of time could translate it. For in the end, perhaps the pattern we found in the void was not from beyond the stars, but from within the listener. Proof not that something out there was speaking, but that we had finally learned to hear by the time the story of Three-Eye Atlas began to fade from public memory. Those who had lived inside its orbit still carried it like an unfinished sentence. It had changed them, though not in the ways they expected. They had gone searching for an object, for data, confirmation, light curves, and measurable truths. But what they found instead was a mirror. The phenomenon had left an imprint not only on their instruments, but on their understanding of what it meant to observe. In the years that followed, the surviving researchers rarely spoke of the object directly, yet their notebooks, their letters, and the quiet interviews conducted long after retirement tell the same story. That once you have seen the universe answer, even faintly, you're never the same. One astrophysicist who had worked at JPL during the lockdown described the experience as a turning of direction. She said the data sessions stopped feeling like study and started to feel like participation, as though every plotted graph, every signal recalibration was part of a conversation too large for language. The strange part, she said, wasn't that we thought it was alive. It was that for a brief time we felt as though we were. Her tone carried no mysticism, only the weight of someone who had spent too long looking at things that do not look back, until one finally did. Across the Atlantic, an ESA spectroscopist kept a handwritten journal throughout the months following the disappearance. In one entry he wrote, "When the signal stopped, I didn't feel relief. I felt watched." Later he crossed out the last word and replaced it with remembered. He never published again. Friends said he turned his attention to teaching, where his lectures became less about astrophysics and more about wonder, about the difference between measurement and understanding. The data was flawless, one of his students recalled, but what stayed with him wasn't the numbers, it was the silence that followed them. At a small observatory in Chile, a technician who had processed infrared telemetry described her dreams during that time. In them, she stood inside a field of light that shifted when she breathed. It wasn't frightening, she said in an interview decades later, it just felt aware. When asked if she thought it meant anything, she smiled. "Meaning is what we do to silence," she said. "We translate it into something we can live with." Among the researchers, there was no consensus about what had truly happened. Some remained faithful to physics, to the belief that the mystery would, someday, yield to explanation. Others quietly let go of the need for closure, choosing instead to dwell in the liminal space between known and unknown. For them, Three-Eye Atlas was not an anomaly but a reminder that observation is not possession and that the universe, in all its vastness, remains gloriously indifferent to our need for answers. A few of them met years later at a symposium about the philosophy of science. They spoke not of data, but of the strange intimacy that arises when something cosmic brushes against human attention. One of them described how, during the height of the phenomenon, she would step outside the observatory each night, remove her headset and listen to the wind. After a while, she said, I couldn't tell which felt more real, the wind or the noise from the receiver. Another confessed that he still avoided looking at the region of sky where Three-Eye Atlas had once glided. Not because I'm afraid, he explained, because every time I look, I expect it to be there again, and I'm not sure I could bear to see it. In one archived email chain from that era, an unnamed NASA administrator wrote to a colleague, I keep thinking about what it means that light can remember where it's been. Maybe the universe keeps a kind of diary, one we only ever glimpse by accident. The recipient never replied, but at the bottom of the thread, in a later printout, someone had scribbled in pencil, and maybe we're one of its entries. Over time, the story of Three-Eye Atlas became a quiet myth among scientists, a campfire tale for the empirical mind, not a warning, but a parable about the limits of inquiry. The object had come from beyond the stars, crossed our orbit, reflected our light, and left behind a silence so articulate that it reshaped how we define discovery. For some, that silence was maddening. For others, it was sacred. In a recorded interview decades later, one of the youngest engineers from the project was asked what she'd learned from it all. She took a long pause before answering. That curiosity, she said, is a form of faith, not in answers, but in the belief that there's something worth asking about, she smiled faintly. The universe doesn't promise revelation, it only promises presence. Even those who rejected the metaphysical interpretations admitted that something intangible had shifted. They found themselves listening differently, not only to the sky, but to everything, to the hum of machines, the faint tremor of wind against radio dishes, the almost imperceptible heartbeat of Earth itself. After 3 Atlas, silence no longer meant absence, it meant potential. At one final symposium, a physicist who had spent her career studying cosmic radiation concluded her talk with a single sentence that would later be quoted in textbooks. Perhaps the greatest discovery was not in the stars but in ourselves, in realizing that even our instruments are extensions of longing. When she stepped down from the stage, no one applauded for several seconds. It wasn't out of disagreement but reverence, because everyone in that room, whether skeptic or believer, knew exactly what she meant. In the end, the legacy of 3I Atlas wasn't the data it left behind, but the transformation it caused in those who searched for it. They had chased a signal across the void and found a reflection of their own need to be witnessed. The boundaries between observer and observed had blurred, and what remained was something more human than cosmic. The awareness that every act of looking is, in itself, a form of connection, and so they carried that awareness quietly into other projects, other discoveries, other nights beneath indifferent stars. They learned to measure without demanding, to listen without expectation, and to accept that some mysteries exist not to be solved, but to be accompanied. For perhaps that is what the object had been trying to teach them all along, that the universe does not speak in declarations but in mirrors, and when those mirrors fade, the reflection remains, waiting for another gaze, another question, another fragile moment when curiosity and existence briefly recognize one another and remember. Because in the end, that may be all the universe ever needed from us. Not belief, not mastery, but attention. Years have passed, and the instruments that once strained to follow 3 Atlas now listen to other skies. The telescopes are older, their mirrors weathered by dust and time. The scientists have moved on to new missions, new mysteries. Yet, in every control room, in every quiet observatory where light still hums through machinery, the story lingers, not as data, not as theory, but as atmosphere. It exists in the pauses between transmissions, in the stillness before a new signal arrives. Something of that object, that visitor, that reflection, has settled into the rhythm of how humanity now listens to the universe. Officially, it remains an anomaly. The archived reports speak with precision and restraint. Object of interstellar origin, unclassified photometric irregularities, observation terminated due to data instability. A tidy summary for what was anything but tidy. Yet behind those bureaucratic lines lies a ghost that refuses to fade, not in the cosmos, but in us. The people who witnessed it still write about it in quiet essays and unpublished papers, describing not what they saw, but what they felt. The sense of having brushed against something vast, something that turned its face just long enough for us to glimpse our own reflection in it. In a sense, that's all any observation has ever been. Every telescope, every receiver, every mirrored dish is an act of self-recognition. We reach outward, and the universe answers not in language, but in symmetry. It gives back what we send, transformed, scattered, delayed, imperfect, yet undeniably ours. Perhaps that was 3 Atlas's final gesture, to show us that light itself is never solitary, that even in the loneliest reaches of space, every photon carries history, memory, and return. Decades after the signal went silent, a graduate student at Caltech stumbled upon an old recording from one of the decommissioned antennas used during the original monitoring campaign. The file was mislabeled and nearly erased, but when restored, it revealed faint traces of rhythmic modulation buried deep in the static, the same 17-minute interval that had haunted the data years before. The pattern was too faint to mean anything, yet the discovery reignited the old questions. Had the signal ever truly stopped, or had it simply fallen below the threshold of our attention? The university issued no announcement. The student filed her findings quietly into the archives, adding only a single note to the file. If the sky still remembers, it remembers softly. And with that, the story began to feel less like a mystery and more like a parable. one written not in words, but in wavelengths. For the scientists who had been there at the beginning, time softened the edges of belief. What once felt impossible became intimate. They no longer spoke of transmissions or responses, but of resonance, that subtle mutual trembling that occurs when one thing, somewhere, vibrates in sympathy with another far away. The more they thought about it, the more it seemed that every act of curiosity, every scientific question, was a form of resonance, the human mind stirring in rhythm with the universe's quiet hum. One of the oldest surviving members of the original research team once remarked in a documentary, "We used to think the mystery was out there, but now I think it was always about what happens in here, in the space between knowing and wonder." His hands trembled slightly as he spoke, but his voice carried the calm of someone who had made peace with uncertainty. In the years that followed, students continued to revisit the data, not to solve it, but to feel it. They turned the frequencies into soundscapes, art installations, and meditations. Some of those compositions played in museums, others in planetariums where visitors lay beneath domes of projected stars. They listened, eyes closed, to the hum that once puzzled the world's greatest observatories. To them, it wasn't science anymore, it was prayer. And perhaps that's what 3 Atlas had always been. Not a discovery, but a form of worship disguised as observation. A moment when humanity looked outward and found something that demanded reverence instead of explanation. A cosmic mirror reminding us that to search for meaning in the stars is also to illuminate the dark corners within ourselves. Today, no one knows if the object still exists. If it continues its slow drift into the cold geometry of the galactic tide, it has long since left the reach of our instruments. It may have dissolved entirely, dust again among dust, or it may still be gliding silently through the void, carrying within it the memory of having once been seen. Either way, its presence endures in subtler forms, in the design of new telescopes, in the way researchers pause before naming anomalies, in the quiet humility that has crept back into the language of science. Because that, more than anything, was its true legacy. Not proof of life beyond, but proof of life within. The understanding that mystery is not a barrier to knowledge, but the source of it. That awe, when unmeasured, can still be evidence. If one listens to the background noise of the universe long enough, a strange thing happens. The static begins to sound like breathing. Not of machines, nor of stars, but of existence itself. Each hiss, each faint fluctuation, a reminder that the cosmos is not mute, only subtle. The language it speaks is time, and we are still learning how to listen. And so, the story closes where it began, with a signal that was never meant for us, and a silence that somehow was. The instruments no longer hear it, but the mind does. That lingering pulse that reminds us why we look up at all. For in the act of listening, we become part of the conversation. And perhaps that is the quiet gift of 3i Atlas, that it taught us how to hear the universe not as a riddle to be solved, but as a presence to be felt. That some signals are not lost, only transformed into a deeper kind of echo, one that resonates through the corridors of our thought, our wonder, our need to belong to something infinite. The object is gone, but its silence remains, steady, patient, luminous. Not an ending, but a continuation. A reminder that when the last signal fades, what remains is not absence but awareness, the delicate realization that even the quietest parts of the cosmos still remember being seen.